So why do we even need to consider gearing calculations? Mainly because internal combustion engines give us different results for different RPM. We've got our torque curve, which peaks at a certain point. We've got our fuel consumption curve, which is lowest at a certain point. We've got horsepower curves that are different at different points. And we need to match up the engine RPM with the desired vehicle speed. Most cars are built probably with fuel economy in mind. That's the name of the game. So they're usually set up for the cruising speed. So they're trying to find the sweet spot here for fuel efficiency. Being a little bit of a droop right here, that's the range where they're trying to get your cruising speed set up in most of your on-highway driving. So there's three main components we consider for overall gearing. Their tire size, axle gearing, axle ratio, and the transmission gearing. Tire size is specifically for the diameter and the revolutions per mile. That's where the gearing calculation comes in on tires. What calculations do we need to make? There are two basic calculations we want to make to find out what would happen to speed or RPM if changing to different size tires or different axle ratio or different transmission ratios. Finding miles per hour is probably the most common calculation used. That's when people already know the values for their ratio or their tires or their overdrive, and they just want to do what ifs on changing one of those. What would that do to change their miles per hour? Number two, you might want to find optimal values for tire size. Let's say you don't even know where to start and you want to solve for ratio. You want to solve for tires. You want to solve for a different overdrive. Now, this is not going to give you exact quantities that you can go out and buy, but it'll get you in the ballpark of what you should be looking for. There's a lot of good calculators online to find these answers with, but what if you have no internet access or desire to find the websites? There are 5 simple calculator formulas which, when entered just as shown, will give the answer. Let's pull up a calculator and do miles per hour. I've got some sample values right here. And we're going to use the formulas here to make this. So we're going to take RPM, which we're going to say is 2300. And it says divided by, which is a backslash in the formula, but it's divided by the tire revolutions per mile, which is 593, 593 times 60. Times 60 divided by the ratio 456 divided by the overdrive 0.75 equals, and there's our miles per hour right there. This was also done in Excel with this formula right here for the same exact calculation that we did here. Here's some more notes on these formulas and how they can be used. Pause or take a screenshot if you like. These formulas can also be kept on Excel or similar spreadsheets, and having the formulas on a spreadsheet is nice to have for finding answers quickly by filling or changing 4 of the 5 values. That way you don't have to enter the formula every time, just make the changes. Here's a worksheet for finding miles per hour. You've got your RPM, tire revolutions per mile, ratio, and overdrive. And the formula is right here. That's the formula. If I double click that, that's saying that it equals B3, which is the ratio, divided by B4, which is tire revs per mile, times 60, which is going to be a constant because we're dealing with miles per hour and revolutions per minute, and the conversion is 60 between hours and minute, divided by B5, which is the ratio, divided by B6, which is the overdrive. This spreadsheet formula that I've entered on the simple mile per hour tab, it's possible to get all of these variables all on one sheet very easily. You can use a little bit of formatting to help you remember which cells to change with a little bit of gray formatting. And for each one of these, you just put in the formula as I showed you before for each one of these. I'm going to do probably the most common one here is miles per hour. It's most often used because you usually know what your car or truck is set up with already, and you're kind of doing a what if I change this, or what if I change that. So a lot of this can be done right here. These over here are more for finding the optimum ratio, the optimum overdrive, the optimum tire revolutions per mile, when you don't even know where to start, or you don't even know what the choices are before you go looking for a choice. This will get you in the ballpark of what you're looking for. These happen to be set up with just the right numbers for RPM, so that they'll come out in even numbers and also available ratios, even miles per hour. These are all available equipment here. I mean, if you change this and you wanted to know for 3,000 RPM, that would be the ratio that you're looking for is closer to a 476 instead of a 456. So, and it's just an example. So let's do a scenario here where you know what you've got and you're trying to find miles per hour for something that you want to change. So let's say that something is tires. And let's say you're already running, let's say you're already running 15-inch rims on Wrangler Boulder MTs on 15-inch rims. They're advertised as 33-inch tire, but they're actually 32 3/4, which falls right in between these two on this. So the tire revolution per minute is 635s. So let's put 635s in here. So you're running, right now you're running about 79 miles an hour at 28, almost 2,900 RPM. And you'd like to see if you can change this by changing your tire size. So you find these Wrangler Boulder MTs on 20-inch wheels. They're advertised as 35-inch tires. They're actually 34 3/4, which falls right between these two in the chart. And so does the tire revolutions per mile. So let's change this to a 598, from 635 to 598, and hit enter. Now we've got 84 miles per hour at the same RPM. On the same workbook, you can have other pages where you can keep handy information, like the tire revolutions per mile chart that I showed you before. You can keep some transmission information here for different transmissions, so that you always know what the overdrive is, what the choices are for overdrive. It's nice to have everything in one workbook. So, okay, well, those of you who already understand Excel, thanks for watching, and anybody that wants to go in more in depth on how to set this up for an Excel formula, stick around. I'll do that right now. So here's the sheet that I had set up for basic miles per hour, and all I did here was I opened it up in Excel workbook. I'll put it more like it probably was when I did all this. Go ahead and type your formula in here so that you can look at it while you're doing this. And then make a column here for RPM, tire revolutions per mile, ratio, overdrive, and then the result, miles per hour. If you double click right here, it'll automatically size that column for the longest thing that's in the column. Okay? And go ahead and put some sample values in here. Put 2,300, and then put your tire revs per mile. You need to know these four to solve this one. Put in your ratio, put in your overdrive. And then when it comes to this, that's the formula that you're going to want to enter. And it's the same as the formula that's right here, except for RPM is at that cell, and tire revolutions per mile times 60 is in that cell. Actually, tire revolutions per mile is in that cell, and you can enter times 60 in your formula right there. And your ratio is right there, overdrive. So, right next to this, I'm going to build another formula. I'm going to build another formula cell just like this one and show you what I'm doing. I put in the equal sign, and I want RPM, so I click the cell with the RPM in it. And then I want divided by, so I click a backslash. and it's tire revolutions per minute, so I'm going to click the cell with tire revolutions per mile in it. Tire revolutions per mile times 60. So I'm going to hit the asterisk and enter 60. Oops, 60, Brian, not 50. And then the backslash divided by ratio divided by backslash overdrive. And now I've got my formula written in there, and all I do is hit enter. And you'll see that that's the same result as that, although Excel likes to carry it out to ridiculous, a ridiculous number of, so you can actually use this right here to lengthen or shorten your decimal places. And I like one decimal place in there just so I know that it's not, if it's 64, is that's 63.5 or 63.9? I kind of want to know that, so I like to leave one in there.